Tiny house electric, equally as important as tiny house plumbing. The Oculus North, which you're looking at there, is a fully off-grid capable tiny house that my company Tiny Industrial builds. You're staring at 500 watts of solar on the roof with the addition of also wind, 400 watts of wind power. And in this video, I'm going to talk to you about the internal aspects of the power in this house for both on and off-grid usage. Enjoy. Okay, the next stop on the tiny house systems tour is the electric. We have a tiny house which is going to be destined for mostly off-grid use. So there is very little, if ever, need to plug this house in. There's going to be 900 watts of solar and wind power collected with this house. So the power hookup here is really more of an afterthought, and it is really just for the odd occasion. Hence, the connector is a rather small, sort of 12-13 amp service here, and no need for a 30 or a 50 amp as some tiny houses have. It is connected right now to a standard extension cord, and it goes into this connector right here, which passes through the wall. There will obviously be siding and stuff added to the exterior of the house. Much like the water here will get cleaned up and into a garden hose connector. Much similar thing will happen here. It comes with this little enclosure, which is really great. So right now, this house is plugged in here into this wall outlet. So let's go inside and take a look at what's going on here from the point where it comes in. So right there is where it passes through the wall, and then it goes into that little box. I always like using these little boxes if and when I'm connecting something. So that connects into this cord down here, and that cord feeds into the heart of this electrical setup. The heart of this electrical setup is this box right here, which is the distribution panel. So what this is a progressive dynamics panel. This panel is being used for several different purposes. First and foremost, it is a low voltage distribution system. It is a battery charger for when you are on grid, and it is also a provider of AC power, albeit very minimal, when you are connected, as we are right now. For example, let's talk about that first. That light over there is plugged into this outlet, which happens to be the only AC outlet in the entire house, and it's kind of hidden under here because it is going to not be in use most of the time, because this is kind of a storage area under the bed. And so it's kind of like a secret stealth outlet, because again, I don't want people to think that that's an actual live outlet, because unless the house is plugged in, as it is right now, that outlet will be non-functional. The AC portion of this setup into these two 15 amp breakers, and what those do is the following. So that the one outlet that you see is hooked up, so the power comes in here, it's shared through this one. This one will then goes and feeds the outlet that we just saw. But the beauty of this RV style panel is that you have this whole section over here, which is your DC section. So this is the whole 12 volt section. Now, when we're plugged in like this, one of these breakers feeds electricity into the DC portion of this. What happens there is that you have all these various connectors here. You have 12 different DC connectors. And currently there's no fuses in here. It uses the those standard small auto fuses that I just had in my hand. These, we've all seen these if you've ever changed a fuse in a car. These are various, they're color-coded to various amps breakerage. So those slot into there. And once you connect that, you're effectively bridging the positive pole on this side with the wire that heads out of this panel. And we're going to see that in a second. On this side. So you're bridging, 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 bridging. Okay. So that's the distribution panel aspect that I was talking about. Now up here, you have these two connectors, this one positive, this one negative, and these two connectors are connected back to one of these batteries. We'll get to those in a second as well. Now, in a situation that we're in right now where we are connected, the house is hooked up, these two battery connectors here, there is a battery connected to it, are charging the battery. So this works as a charger for the batteries. So absent solar, absent wind energy, we are now charging the battery without having a need to rely on solar for that. There is additional space for additional breakers, so if you wanted to add more utility in terms of the 110 voltage side, you can do that. All of these wires that I showed you before, these 12 connectors, again, none of these are bridged yet, but all of these will run into one of these wires, and that is the distribution of the electricity. Now what I did here, because I like things to be fairly neat, is I got this is an plastic ammunition can from Harbor Freight, and all of these wires run out of the back of the panel and into here. And what I did is I matched up each one of those exit wires, and they all are number coded with, let me get some better light. Here, hold on. There we go. So each one of those wires, the black ones, has a number on it, which corresponds to the circuit on the front. Now the metal bar that you see in there is all your negative connections. So the wires coming out of the panel are your positive, and all the negatives terminate in this bus bar. So what that does is it creates a common ground for all your connections. And then you have a bunch of things that you want to power in the house. They all come in via that route. The negative gets connected to the shared bus bar. The positive gets connected to the corresponding circuit in the front. And I did like these little dashes on the wires to symbolize which circuit was being connected, because you wind up with a lot of wires, and those wires come out of there. Again, for neatness sake, I wrapped them in this wire organizer, I guess it's called. And then that runs over here, and then the electrical distribution occurs from this point. You have a number of wires, and each and every entity in this house has its own wire. Some people use a common ground wire. I'm not a big fan of that. I like running all the wires back into this box and then connecting them all via that bus bar. So you have one wire lying on the floor right there, which is going to go to the pump. That needs power. Then you have a string of these wires running out over here. You have one that terminates there, and I label all of them with a little piece of painter's tape, just so I know what's what, both on the front and the back end. And that, for example, is to power the 12-volt fridge. And then you have one that branches off up here, runs up here. This is going to be the electrical connector, the ignition effectively, for the on-demand hot water heater that needs a 12-volt connection. Then you have this wire right here, which runs into this box. That is going to be the bathroom lighting, low voltage bathroom lighting, which will continue on through this after post switch. You have, well, this wire right here is a bit of an anomaly. That's going to be the thermostat for the heater that you see down here. So that's a thermostat wire. That does not go back to the panel. This one here, this one, you can't see it, but it says heater. And this is going to be the hot air propane fired heater. Again, that needs power for both the fan and for the ignition. Then we have back here, we have one more wire that's going to go back here, and that is for the exhaust fan in the separate composting toilet. So that has a small sort of computer style fan in it, which extracts air from the chamber in there, and you know, keeps things smelling nice and dries things out. So yeah, so you have a multitude of these wires. There's the other half of the house as well. There's one that runs out this way and up into here. And what I did here is I used just a single wire run to split into 3 different wire runs. There's going to be switches in here. You're going to have an exterior light switch. You're going to have a main interior light switch, and you're going to have a kitchen light switch. So main interior light will be up here somewhere, and hence it terminates up here somewhere. Then you have exterior light. There's going to be a fan up here above the shower area. That's going to get an additional controller, which is going to go right here. It's sort of a speed controller, 12-volt speed controller. And then we also have one more line coming down here, which is the thermostat that I showed you on the other side. So there's going to be a thermostat panel here, and that connects over to the heater. So that's going to be your thermostat location right there. But again, it's yeah, this one right here was the aforementioned kitchen lighting. So that's going to run up through the ceiling and light some probably recessed ceiling lights over the kitchen. So that's effectively it. Let's spend a moment talking about the batteries. So I have them kind of temporarily hooked up here. They're not connected to each other. I have one battery right now which is running a fan, mostly to just test out the battery a little bit and to test out this little panel that I have. So you do want to monitor your energy usage, and they sell these little panels on Amazon. And what this is telling you is the current voltage in the battery, how much current you're drawing on that battery, and how many watts, 3.4 watts in this case. And then you have a running tally of watt hours in the bottom right hand corner there. So if I stop this fan, you'll see you know, there's no more usage, but the fan will momentarily restart. There it goes, and you're showing usage again. So that's kind of a cool thing. So right now this is just hooked up independently, and I'm just trying to see. This fan's been running for about 24 hours. So these batteries have over 100 amp hours each. They're deep cycle batteries, which is what you want. Again, links in the description. They're VMAXs. And these are going to be connected in series. These are 12 volts. So you're going to connect the positive pole up here to the positive pole there via wires such as this. What that does is it creates one big 12-volt battery versus 2 independent ones. So you can connect those together. Currently, I only have this one battery hooked up. So you see this thinner red wire here and this black wire up here. Those are the ones that are running into the panel to those two, where is it? There, those 2 ports right there, red, and then black goes into that. So if I were to disconnect the power that's going into the house right now, first thing that would happen is that light would go out, because we now no longer have the AC that is drawing on. And what would happen is the battery would stop charging. The power draw in the house would then come from the battery. So to show you what that looks like, I can do this here on this multimeter. So if I could take a look at the positive here and the negative, we got like 12 volts coming in. There's a 1 missing there. So that's working. And what you'll see is if I click these off, the breaker's off. So now we're basically disconnecting the outside power. It gets dark in here. Yeah, since it's really hard to see. Since the battery is fully charged, we've still got sort of similar power there, but now we're on battery power. So battery power is great because you can charge it, like I said, through this. I'm going to just turn this back on just for lighting purposes. So the battery is great because you can power things in the house off of the battery via this distribution panel. But you can also convert this 12 volt energy back to AC to power something like this. And the way that you do that is by way of one of these converters. This happens to be a 1000-watt converter. And it takes the power in the back here, those are the 2 thick cords coming off of there. They go into the back of this inverter, and what this inverter does is when you switch it on, it gears up and powers up this one outlet here in the front. Now, if I take this light, unplug it, sorry for the jostling. We're going to plug the light into the inverter. Okay, that's now plugged into there. And then if we switch the light back on, if I can do this with one hand, come on, without burning my fingers. There we go. That is now being powered by this. And to prove that, we've got currently we still have power coming into the house, right? But if we click off the breakers, guess what? We still have light. This happens to be a 500-watt shop light, very bright, puts out a lot of heat, uses a lot of electricity. And this thing right now is powering that. So what's going to happen here, since this is coming off of that battery, is we're now drawing down that battery. We're no longer supplying the panel with any external power because these 2 breakers have both been switched off. The battery is still powering this panel, so you would still have all these circuits available to you, but it is also powering this. So we're drawing down the battery right now. What's going to happen is this has some cooling fans in it because converting this 12 volts back to 110 is generates some heat, and there's some efficiency loss there. So this will have some fans that will kick on, and at some point, this battery would just be depleted. This would not have enough power anymore, and it would no longer be running this light. The point is that I wish the fan would kick on in here so you can hear that. It vents out the back here. Hold on. Right there. You can see the fans. So that's how that works. What will happen is if I switch these on again, this part of the panel will recognize that the battery is not topped off and will proceed to charge the battery. It does so at various rates. So if the battery is almost full, it will very gently charge it. If it's very low, it will more aggressively charge it. That in turn, generates some heat on this side, and that's why this has a cooling fan as well. So the charging of the battery may cycle that fan on and off. But yeah, we have this going on. If we check here again in terms of the voltage, let's turn this on. Yeah, so now we're starting to drop a little bit. Dropping a little bit. If we click on power in the house again, you can see that jumps up on these ports, because now the power supply here in the panel is now looking to charge those batteries again, so to resupply them. What will likely happen is that that's going to warm that up in there. Fan will kick on. Meanwhile, we're still drawing power out of the inverter here to power this light. But it's a pretty cool setup. It works great. I've used this in my other tiny house. I've done this setup before. Really like this panel because it covers so many bases in terms of both on-grid and off-grid usage. Anyway, that's it for the electrical. This will also need to find a home somewhere in here. It may go next to the panel. Don't know. There you go. What a fitting way to end. So this has generated enough heat for those fans to kick on. One thing this whole system is still missing is a sort of master on-off switch. And what I'm going to do is I'm going to run all the positives through here. So they'll come in here, they'll exit here and go to the battery. And what this will do is all the various inputs of power, whether it's from the panel, whether it's from the solar setup, it will be able to be turned on and off right here by this switch. This is a marine switch, and what this does is just it's a safety device effectively. So if you're having a problem with the electrical somewhere in the house, disconnect the batteries, disconnect the power via this route, and then you're all set. So that's just a safety precaution that you should always have. Master electric shut-off. All right, that's it for now. And this hasn't kicked on, but it could. Let's see if this is generating any heat. Yeah, it's getting a little bit warm. But yeah, that's what we have so far. And again, links to all these components will be provided as well. Thanks for watching. Okay, so that's it. That's the electrical setup. Now, what I didn't get to and what I didn't go into any detail on is the solar aspects of it. So briefly, there's 500 watts of solar on the roof. They feed into a solar charge controller, and then that solar charge controller feeds into the batteries that you saw in the video. So that's a completely separate setup, right? It has nothing to do with anything I explained, and you're effectively just creating two different means to charge those batteries, whether you plug the house in and the panel charges the batteries, or whether you're off-grid and you rely on the solar to charge the batteries. The setup is exactly the same, and those two systems are completely distinct and autonomous from one another. Hope that helps. Hit subscribe, enjoy, and good luck.